Hello everyone, my name is Ajay and this is going to be the Docker networking series. We are going to talk about how these Docker containers can talk to each other, how can they talk to outside to connect non-Docker workloads. And we are also going to discuss some of the basic of Docker container, what it is, why we should use it, etc. So let's start. Basically, these Docker containers, they can connect to other containers or they can connect to the non-Docker workload via your host machine. All this communication has to be facilitated by networking layer. As you see on my screen, there are multiple network drivers comes for Docker, which is going to be the host, overlay, MAC VLAN, bridge, none, and IP VLAN. By default, you are going to see host, bridge, and none. And for all these network drivers, there are going to be different use cases, which we are going to discuss going forward. As of now, let's understand the overall concept. So Docker containers, they run on the guest OS. Basically, here we are talking about how to do the virtualization on OS. There is going to be the shared kernel, and top of that, you are going to install the Docker engine. Then you are going to run your application as container. And those are going to be the isolated from each other. These Docker containers basically going to have the endpoints, and you can have multiple endpoints basically. For example, one endpoint can be used for the data traffic, another one can be used for the management. Similarly, there's another container which is C2, and you are going to have same setup. While building the network to communicate between the Docker or maybe outside of Docker, you need a networking layer. So let's understand what is Docker. So Docker basically creates a universal packaging approach that bundles up all the application along with the dependency inside a container, which is run on the Docker engine. It is available for Linux. You can install it on the Mac and also on the Windows based system. There are going to be a couple of standard feature or offering from the Docker. It is going to be the standard, lightweight, secure, and obviously it is an open source platform which is fast and high performance. There are going to be the two options. Either you can go for the community version, which is free, or you can go for the business. For that is something which is paid subscription based. As I mentioned earlier, Docker is open source. It is available for Mac, Windows, and Linux. Let's talk about the Docker features. As I mentioned, it is going to be the standard offering. So Docker packages software into standardized units called containers. And that has everything that the software need to run, including all the libraries, system tool, code, and runtime. That makes it standard. The second feature is going to be the lightweight. So obviously it doesn't need any separate OS like VMs or the virtual machines for each application. That makes it lightweight. And top of that, it runs faster to stop and start functions along with the shared kernel. So you don't need separate OS, and it is going to be the shared kernel. That makes it lightweight. Once it is lightweight, it is very easy to start and stop. That's going to be very, very fast operations. It is secure. So containers isolation, that is a native control that makes it more secure. What it mean? For example, you have three containers, C1, C2, and C3. Though they are running on the same OS, they will not be aware about each other existence. So C1 cannot communicate to C2, C1 cannot communicate to C3, and C2 cannot communicate to C3, though they are residing on the same OS. It is open source platform, and since it is a very lightweight, that gives you a faster response and the high performance. There are two ways available how you can virtualize an environment using the hypervisor. So type 1 hypervisor and type 2 hypervisor. So type 1 hypervisor, basically when you have the bare metal server and you want to virtualize that. So on top of the hardware layer, you are going to add a hypervisor. On top of the hypervisor, you are going to run those guest OS where you are going to install multiple apps. So example for type 1 can be your Citrix, Zen Server, VMware ESXi, or you can go for Hyper-V. When coming back to Hyper 2 hypervisor is the hypervisor which is running on top of the OS. So you have hardware, on top of that you are running some sort of the OS, and then you're running the hypervisor. On top of the hypervisor you are running your guest OS. So the great examples can be your Oracle Virtual Box, which you can install on your OS, VMware Workstation. Those are two very famous hypervisors available in the market. So in this example, you can see this is the hardware piece. On top of that, you're creating four VMs. So VM 1, 2, 3, and 4. You're going to install separate OS for each VM. This kernel is going to be dedicated for that particular OS. On top of that, you're going to run those apps. So app 1, app 2, app 3, app 4. For a moment, let's just assume you want to run some sort of web application, maybe Nginx or Apache. You cannot install two instances on the same OS because there's a limitation with the socket. You cannot use the same socket number or the same port number for two applications. That is how it is going to look like. And when it comes to the process, those processes are going to be separate and there's not going to be any dependency on any other machine. So it is all individual VMs running on hypervisor layer. When it comes to the container, it is going to be the virtualization of OS. So you are going to have the guest OS, whether you want to run it on the individual machine or you want to use it on different VMs. There's going to be a shared kernel across these four containers. And in between, instead of hypervisor layer, you are going to have the Docker engine. These four containers, they are going to run in an isolated environment, having no dependency as such from each other. So you can assume it is like running a process on your guest OS. This is the official Docker architecture. You are going to have a client. If you are run a command like docker build, docker run, or docker pull from your Linux machine, that is going to act as a client. On the Windows machine, when you install the Docker desktop, it comes inbuilt. Then you are going to have the Docker host, and this Docker daemon is going to run the host machine. This is the container you can host, and there's going to be the image repository. Initial image comes from official Docker registry, and that is going to be the read-only thing. And once these images are downloaded to your local repository, you can customize it, ship it back to your own registry, or you can distribute to whosoever wants to run your customized image. Now let's try to understand how it helps in SDLC, the software development process. So for example, this is your dev environment, this is your cat environment, and this is your prod. In the dev environment, somebody has developed some sort of the Python script, and that was generated from Python 3.8. That image goes to your GitHub, and in your cat environment where you want to fix your bug or you have the tester setting, they are going to download that particular image. If it is a bug free, it goes to your prod environment. The challenge you might have in dev environment, they might be using 3.8. In cat, it might be 3.7, and in prod, it might be 3.9. And sometimes what will happen, the script which works in dev environment might not work in cat, or if it works in cat, it might not work in prod. There are always going to be some sort of the dependency, and you will have to be on the same platform when it comes to all the three departments. Technically, or I would say in reality, it is not possible. Somewhere you will say some patching is missing, somewhere you see they are not running on the same platform. So what happens? A dev engineer says it perfectly works. When it goes to the prod, it fails. So that is main pain point how we deal with. When it comes to the Docker, it helps fixing this problematic area. So let's try to understand how Docker helps to fix this painful area. So a developer is putting a code to the GitHub. That code comes to cat, and once these department says this code works perfectly fine, you're going to introduce a new layer, and that new layer is going to be your Docker repository. So you are going to build a container that is going to have code, and that is also going to have all the dependencies. So if a particular app that works here, you are going to ship same thing to Docker with all its dependency. And when it goes to the prod, you are going to get the same container here that comes inbuilt with all the dependencies, maybe on the OS or maybe on the libraries. Everything is going to be as it is. So if a solution or a application which works in cat environment, it will be guaranteed that it will work in a prod environment as well. Let's take a look on the Docker installation. And this is a machine which I'm running on Azure Cloud, and it's a Linux. So let's first test what is its version. So you can run this command lsp underscore release underscore d, and we can see this is a Ubuntu machine which is running a code 20.04.4. And with the Docker hyphen version, you can see I do not have any Docker installed as such on this machine. However, this is going to give you a command which you can run to install the Docker. Before installing Docker, update your system with this command. And once it is done, go for the next step. You don't even need to remember the exec command what you're going to run. So for example, if I just type docker install, it is going to return a command. I need to run apt install docker.io to get the Docker installed on this machine. And when you run this command, it is going to download all the packages needed to install the Docker here, and you need to press yes. You can see there's a progress which is 78, and it will be completed once it is 100%. When Docker is installed on this Linux box, let's take a look what is the version. So if you type docker hyphen version, it is going to tell you the Docker version which got installed just now is 20.10.12, and build is also 20.10.12 and it is Ubuntu. With the command sudo apt-get remove docker.io, you can also remove the Docker installation we have done so far. You need to press yes to continue, and we see once that is completed, I do not have any Docker image running here. For more installation on Docker installation, you can visit the official website of Docker. And there's another portion which is mentioned over there, which is going to be the convenience script. You can simply run the script and get the Docker installed on your machine. So there are going to be always two environments. One is going to be get-docker and test-docker. So one is which is basically referring to your stable version of the Docker, and this one is referring to the beta. So make sure you read the script and then you can realize what is Docker version it is going to install your machine. To read more about the script, you can browse these URLs from your browser. Go for the test.docker.com or you can go for get.docker.com and you can read these scripts. Let's talk about file transfer. So you have a host. On top of that, you might be running multiple containers and there is one image which is some file. And if you want to transfer this file to your host, you can do it. Similarly, you can transfer if any file which exists basically on the host and you want to transfer it to your container. That is also something doable. You might have this situation, you want to transfer file between the containers. That is also doable. Let's take a look on how to basically get the image from Docker Hub repository. So there's a command which you can run on your machine, which is going to be the Docker space images, and it is telling you nothing since we have not pulled any image from Docker Hub so far. Let's try to pull one image, and that time it is going to be the Nginx. So Docker space pull space Nginx, that is going to be a command, and the tag is going to be the latest one. If you want to change the tag, you need to visit the Docker Hub official website and you can mention tag as well. Now, since we are just giving the pull image, it is not going to run the container, it's just going to download the file. Now we see the output of Docker images. It is telling you this is the image which we pulled from Docker Hub. Its size is going to be 142 MB. This is going to be the image ID. This image was created 2 weeks ago and the tag is going to be the latest. Similarly, you can pull another container. This time let's pull Ubuntu. And now we see there are two images I have in my local repository. Since we have pulled two images from the Docker Hub, and I'm going to run it one by one, hence you see the same IP address is getting allocated to this container. So my first command to run the Ubuntu Docker container is going to be docker space run -it Ubuntu. And the moment you are inside the container, you can pass a command hostname -i, and that is going to return you the IP address which get allocated to your container. Similarly, when you run the Nginx container, run this command to get inside the container, which is going to be the docker exec -ti web/bin/bash. You can pass the same command hostname -i to get the IP address which get allocated to this container. This series will be completely focused on Docker networking, but before we deep dive, we must understand the basic concept, what is Docker, how to run it, and a small concept to make a network running on the Docker. So thank you for watching and I will see you in the next video.